your view of this the call.
Yeah. Okay, so if this will load. Okay, so here's the front page. Okay, so there was a question. The side links we're solving for won't always be whole numbers. That's correct. No, they will not always be whole numbers. Can we plug those side links into the Pythagorean theorem and solve for x? Yes, that's exactly what we're going to do. It is actually x, Ethan, not theta. They use x in this question. Okay, so let's go ahead and get started with talking about this problem. Okay, so number 7, it gives us that A is 2x, B is 5x minus 1, C is x squared plus 1, and this little symbol where it says x is in Z with the double bar. This double barred Z is the set of integers. This font is called Blackboard Math. And whenever you see it, it means the set of, and Z always represents integers. So it's just saying that, and then this thing is an epsilon, and it means is an element of. So when you talk about set theory, sets are groups of things, and elements are the individuals in the group. So it's saying that X is one of the pieces of this particular set. So it's just saying that X is an integer. We have been given the 3 side lengths. And so what we need to do is, since the relationship we know between the sides of a triangle is the Pythagorean theorem, we need to set this up as a Pythagorean theorem problem. I am going to assume that C is the hypotenuse. I feel like it should tell us that. Oh, it gives us a picture. Good. So in the picture in your book, it should have C as the hypotenuse. That's how we know where to put each piece. So we have 2x squared plus 5x minus 1 quantity squared equals x squared plus 1 quantity squared. Okay. So 2x squared is going to be 4x squared. When we square this, we cannot ever square each individual piece. We have to use distribution. So 5x times 5x should give me 25x squared.
Shouldn't that be 4x to the 4th?
No.
Oh.
This was just 2x.
I thought it was 2x squared. My bad.
Yeah, the squared is on the outside. Okay. And then we would have 5x times negative 1, and we would do that twice, so we should get negative 10x. And then negative 1 times negative 1 is positive 1. I'm going to write this one out so that if you had a hard time following me when I distributed this guy, you can maybe follow along with this one. So all we did was we rewrote the square as 2 factors. And this is what we did over here. I just did a lot of it in my head. Then we do the first inside, outside, last, outside, inside, last thing. We take the x squareds and multiply them. We take that and multiply by 1, multiply by 1, and then multiply the ones together. We should end up with x, to the 4th, plus 2x squared plus 1. Sam, it would have been really helpful, though, if this was to the 4th, because then we could subtract it and get rid of it.
I can see another mistake I made. I completely forgot to FOIL, so all my answers are wrong.
Yes, you must do that. That's really important. In my classroom at school, I have a sign that says, "You kill a puppy every time you do this," and it's not foiling.
I killed a puppy.
So we need to combine our like terms. So these 2 squared terms we need to combine. So we'll have 29x to this 2 minus 10x plus 1. And I'm going to go ahead and rewrite it again. So we have everything on the same line. Now we need to combine like terms again. Let's see. So I'm just going to move everything to the left. So I'm going to have negative x to the fourth as my first term. I'm going to start with my highest power. My next highest power is the square. So I'm going to subtract the 2x squared over. 29 minus 2 is 27. We don't have any other x terms, so I'm just going to drop my x term down here. And then the ones should cancel out. Okay. This question, you guys see how at the, well, I guess you can look later, but in your book, it has a little calculator picture on the side. That means that this problem is calculator active. So do you see how we have a quartic function right here, right? And we could factor out an x. Negative x cubed plus 27x minus 10. And then we get this cubic function, but solving cubic functions is not something we've practiced algebraically. And because it's calculator active, and because IB exams go fast, use your calculator to solve this, okay? So we know one of the solutions should be x equals 0 from this guy right here. And the other solution will occur when negative x cubed plus 27x minus 10 is equal to 0. So we should solve that using a calculator. Oh man, and mine's not down here. Man, okay, I'm gonna put it on Desmos, and then from now on, I need to have my graphing calculator down here, so that you guys can see. So all you would need to do is graph the function. You guys are not allowed to use Desmos on your tests, quizzes, or on the IB exam. So this is not a good thing that I'm showing you. I apologize. But for the sake
showing
of,
us inappropriate things.
I know. For the sake of me not having a calculator, let me see if I can make this not switch the blinds the other way. Maybe. I don't know what to do. There. That's better. Okay, so we see we have 3 intersections on here. And you would find those same 3 intersections when you calculated it on your calculator. We would get x equals negative 5.372. X equals 0. No, that's right. 0.372 and x equals 5. So those are our 3 solutions, I guess, or total solutions for x. It says find the value of x and the angles A and B. So what information does it give us in the problem? And I've written it on this paper that tells us which of these 4 values is the true value for x.
Well, since x is an integer, the correct answer would be x equals 5.
Yeah, why not x equals 0? 0 is an integer too.
Because when you plug it into A, the side length is 0. You can't have a side length of 0.
Very good. We want non-zero side lengths. So our 2 qualifications were that we had non-zero side lengths and also that we had an integer. The only one that fits both of those is x equals 5, so that has to be our solution. Then it says find in the angles A and B. A, if you look, I'm going to draw the triangle real quick that it gives you to do this problem with. So we have A, B, and C, little a, little b. So it wants us to find the angles A and B, obviously, because C is a right angle. So A, we need to figure out a relationship between the angle A and the side lengths. What's the relationship? Maurice. Maurice, what relationships do we know that we have between the angles and the side lengths of a triangle? What did we talk about in our trig review?
The sine, cos, and tan.
Yeah, the sine, cosine, and tan. So if we're looking for angle A, what relationship could I use to solve for A? So we have, Maurice, we have all three sides, right?
Mm-hmm.
We could use any combination of those three sides. So we could pick sine, cosine, or tangent. We can pick any of them. So just pick one.
Sine.
Okay, so we'll do the sine of A is going to be equal to, so remember sine is opposite over hypotenuse. So what's the opposite side from angle A?
It's gonna be the A.
Yeah, little a. And then the hypotenuse is?
The C.
Perfect. All right. So you set it up, so you're good to go. So we need to actually figure out what these side lengths are, right? So A was 2x. We figured out what x was. 2 times 5. So A is 10. We also need C. C was x squared plus 1. 5 squared is 25 plus 1, so we should get 26. So the sine of A is going to be equal to 10 over 26. To isolate A, we would take the arcsine of each side. And you can do this on your calculator or on Desmos. Since I'm anyways. 5 degrees or radians. We're going to go with degrees since all of the other problems use degrees.
Los libros que tienes ahí, ¿qué libros son?
I want the arcsine
¿Son para leer o son para escribir?
26. And we should get point.
Uno de aquí y allá. Ya.
Oops.
Porque no te lo sabes. Mami, me está dudando.
There's a setting where we can switch it to radians. That seems like a weird. Oh, it wasn't radians. That's why. Right. In degrees, we should get 22.62 degrees. No worries. You can mute yourself if you want. Unless you have something to say. It's okay. Okay, so what questions do you guys have about solving for that angle A?
I forgot to FOIL, but I got that answer.
That is a coincidence.
Yeah, I think because I came out with x equals 5.4. It was just close enough, probably.
No, that is absolutely not close enough ever. That is a huge margin of error. So you guessed and happened to get it right.
Yes.
Yes, you guessed. If you get 5.5 almost, you definitely cannot round that to an integer. You have to get an exact integer value for it to be an integer. All right, what other questions do you guys have about solving? Finding angle B, you would do the exact same process. You could pick whichever trig function you wanted to solve this.